All right, today in stats we are moving on to I think it's a complicated topic where it's the notation that tends to trip people up. So two things to look at on this screen. This function right here and this function right here. Well, I guess technically that too. And we're talking about two different things. We're talking about finding the mean from a combination of random variables and a standard deviation of the combination of variables. So the mean is a piece of cake. Whatever your function is, whatever it looks like, you plug in the means, corresponding means, and you have the whole mean of the two. So if I'm adding x and y, I plug in the mean of x, mean of y, and I add them together. Very easy. But two things happen with variance, and I feel like our book does a poor job of addressing this. So imagine for a second that instead of just x plus y, I have some coefficient on the front like this. Whoops. Who knows what that coefficient is? Could be positive, could be negative, who knows what. Then the mean is still the same, but standard deviation looks a little bit different. So, like up there in that t function, a1 would be 1 and a2 would be 1 because the coefficients are 1 up there. But on this second function right here that I have circled a bunch of times, y's coefficient is negative 1. So it's kind of hard to see the variance and why we end up with positives. So what happens is you square those coefficients. So for example, sigma t squared would be a1 squared sigma x squared plus a2 squared times sigma y squared. And then lastly, you square root. And you have that. So first thing you need to be aware of is you square everything and you should end up with all positives. The second thing that is true is this last thing that I typed in bold. So if this is not the case, if the multiple random variables being combined are not independent, we can calculate standard deviation, but you would need more information, and that's beyond this class. It's called covariance, and we would go on and get the standard deviation. So it is doable, so be careful. Don't say we cannot calculate it. Just more information is needed, and we would be in luck. So if dependent random variables, then more info needed for combined standard deviation. If they're independent, you just plug them into that formula I wrote in red on the bottom left, and you're good to go. So two things to make sure you account for. You have all positives, you square everything, then you add, and lastly, they do need to be independent. If they are not independent, then you don't even do any math. You just move on with life. All right, so Pete has a sister. We looked at Pete's Jeep tours on Wednesday and Thursday last week, and we found that mean and that standard deviation. Well, he has a sister named Erin who has this distribution, and we saved a little bit of work, and there's the mean, standard deviation. You could do it by hand if you want. We need to find the mean of their total passengers. So let's practice that. All we do is we plug in the mean of x and the mean of y, the mean of Pete and the mean of Erin. So mu t is mu x plus mu x, y. Mu t is 3.75 plus 3.1 mu t is 3.85. Let's find the standard deviation. Also very easy, but start by getting the variance. So I'm going to say sigma squared x plus sigma squared y and finally I get 1.4411 when I square root. Make sure you square root. Don't forget to square root in the very end. What about the difference? So this is when that negative thing comes into play. The mean will be very easy. I'm just simply going to subtract these two. I can do that in my head, I hope. So on average, they have a difference of 0.65 passengers. But standard deviation, this is where it's important, and I kind of skipped it up there on the total for x and y. Technically, let's see if I have room to write this. It's going to make it messy. I have a 1 squared in front of both of those because 1 was the coefficient for x and y. So on this one, I have 1 squared times sigma x squared plus parenthesis negative 1 squared sigma squared y, which then makes that positive, and we end up with the exact same standard deviation we did on total passengers. All right, I hope that made sense. So we're going to press on. We're going to attach costs to this thing. We want to factor in 150 that Pete charges and 175. Ooh, I forgot to point something out. I'm sorry. Back to this one. We can't see it. At the very top of this screen, if you follow the mouse, it says another part of the country is where Erin is doing business. So I forgot to point something out. Since she's doing business in another part of the country, Pete and Erin are independent. If that wasn't true, we couldn't have calculated the last thing, standard deviation. We can find standard deviation. Think about it for a minute. If Pete and Erin were working in the same town doing Jeep tours, if someone picks Pete to do a Jeep tour, they're obviously not going to pick Erin and her business is affected, or vice versa. But yet if they're in different parts of the country, chances of one person going to Pete had no bearing on choosing Erin because they were probably going to Pete's location in the first place. So that was crucial that we were aware of that. If they had been living in the same town, we would have said they are dependent, cannot calculate, or we need more info to calculate standard deviation. Okay, anyways. Back to the cost. So Pete charges $150, Erin charges $175. We want the total cost. So I would write that function like this. Oops. Plug in our means. And our mean total, not cost, amount that they bring in would be 1105. I can do standard deviation. A few more extra steps though. I don't know if I gave myself enough room. I may have to write small. made it. So plug in our standard deviations, and we get 232.27. All right, let's look at one more thing with Pete and Aaron. That's the combined amount of money that they bring in. What if we look at the difference? So we can call that D. The mu D will be 150 mu X minus 175 mu Y. Plug in my two means, and I end up with 20. So $20 is the mean difference. Standard deviation looks a little different. So remember, we're subtracting 175, so I square that coefficient, and I end up with the same exact standard deviation I had a moment ago. Let's fix that dollar sign up there. All right. I'm going to show you one more example in the next video. It's a harder problem, I think. So, see you in that one.